So today we're going to discuss about camera movement, character movement, camera control, and interactions with the game through the collisions in Unity, which lays a foundation for dynamic and interactive gameplay. Uh, in the Hero Bond script, in the Hero Bond project file. So we'll start by understanding how to directly manipulate the object's transform component to move and rotate the player character. This direct manipulation will contrast with movement based on applied force, offering a more nuanced and realistic interaction with the game's physics. So the player input is central to controlling character movement. Will cover how to capture and manage inputs from the keyboard, which is WASD or the arrow keys. So to control the player's movement and rotation, this initial input is crucial for creating a responsive gameplay experience and the feels natural to the player. And we'll also discuss about camera behavior. So camera behavior is another important point of this topic. We'll script the camera to follow the player in a third person perspective, maintaining a specific distance and angle uh, that facilitates navigation and interaction with the game, especially when aiming or exploring. And we'll also discuss about Unity physics system, which plays an important role in making the game world feel real. We'll explore how to use applied force for movement and giving the character motion a sense of weight and momentum. So this approach contrasts with the more immediate response of transform manipulation, explaining different techniques for character control. And we'll also discuss about collision detection and basic colliders. The use of basic colliders will be covered to understand how the player character interacts with the environment and other objects. So this includes picking up items, colliding with obstacles, or triggering events within the game. Understanding Unity's physics and collision detection system is a key to creating engaging and realistic gameplay mechanics. So throughout this topic, these concepts will be tied together through practical examples and exercises in a playable level that, while lacking advanced action mechanics, will serve as a solid base for further development. The focus of C# scripting to implement these features underscores the power of programming in bringing the game concepts to life, offering a hands-on approach to game development in Unity. So, so first topic is player movement. So when programming player movement in Unity, you have several options, each with its own balance between simplicity, realism, and computational demands. So let's break down the common methods for moving your player character. The first one is transform component movement, which is directly manipulating a game's object transform component. It's a simplest method for moving and rotating objects in Unity. So this approach is straightforward and best suited for games where realism in movement isn't the primary concern. It's ideal for beginners or when developing simple 2D games. So we have a rigid body physics. So for more realistic movement, you can attach a rigid body component to your game object and apply forces to it. So this method uses Unity's built-in physics engine to simulate real-world physics such as gravity, friction, resulting in more natural and dynamic movement. So it's particularly effective for 3D games where you want your character interaction with the environment to feel more lifelike. And we have character controllers. So Unity offers specialized components and prefabs like the character controller or the first person controller for managing complex character movements. So these tools abstract away some of the lower level movement mechanics, offering a blend of ease of use and realism. So they're great for quickly getting the character moving in a 3D space with minimal setup. So some of the best practices for this is Unity recommends uh, choosing one method for moving or rotating your game object to avoid conflicts uh, and unexpected behavior. So mixing transform manipulation with rigid body physics, for example, can lead to issues since both systems are trying to control the same object's properties. And starting with transform component movement is a good way to learn the basics of character movement. Later on, integrating the rigid body physics can elevate the realism of your game by introducing real world physics interactions. For those looking to speed up development without sacrificing too much control, the character controller and other Unity provided components can be invaluable resources. So the choice of movement method depends on your game specific needs, your familiarity with the Unity systems. So the level of realism you aim to achieve, starting simple with the transform movement and gradually incorporating rigid body physics or character controllers, can provide a solid foundation for understanding and mastering player movement in Unity. So so to set up a third person adventure game in Unity, you'll start by creating a player character using a capsule game object that we discussed in the last topic, and adding a rigid body component for physics interactions. So let's break that down. So I have already set up everything here to save time. So when you go to hierarchy panel, go to 3D object and you'll find a capsule and name it player for easy identification. I already have a player model. Yeah. So to allow for physics based components and interactions, add a rigid body. I've already added a rigid body uh, to the player. This step is crucial for integrating Unity's physics system with our player character. You can find the rigid body in the add component. So within rigid body constraints, you you can freeze the x and z axis to prevent. I freeze y, but yeah, that's yeah. But yeah, you'll basically freeze the x and z axis to prevent the player capsule from tipping over during movement. So and for visual distinction, you can create a new material in the materials folder, and so I've already created a matte look for the player, and you basically set the albedo property to something bright color, and apply this material to the player capsule to make it stand out in the game environment. And in Unity, vectors are important for defining positions and directions in 3D space. You'll frequently use the vector 3 for 3D movements, which includes x, y, z coordinates. And for example of a vector, example of a vector representing the scene's origin position is vector 3 origin is equal to mu vector 3 0 f, comma 0 f, comma 0 f. Yeah, this is an example for a vector, a vector representing the scene's origin position. So Unity offers directional vectors such as vector 3 dot forward, which represents forward direction along the z-axis. And moving and rotating the player capsule will involve the transform components, translate and rotate methods, which require vector parameters to simplify direction and magnitude of movement. So to move the player based on the keyboard inputs, you'll gather input data and convert it into a vector movements. Unity's input system allows for easy retrieval of keyboard inputs to control the player's movement and actions. While initially movement will be a direct manipulation of transform component, you'll later explore using the rigid body component to apply forces for movement. So this approach offers more natural and realistic movement, but requires a good understanding of Unity's physics systems. So through these steps, you'll set the foundation for the player movement in your game, utilizing both direct transform manipulation and physics-based movement for the third person adventure setup. So this process not only introduces you to the basic game mechanics, but also integrates essential Unity components like rigid body physics, material applications, and vector mathematics for game development. So when you create a vector 3 origin, you're defining a point in 3D space where x, y, z are set to 0. So this can represent the center or the starting point of your game scene. And vector 3 dot forward is a shorthand Unity provides for a vector pointing forward relative to the game's world's orientation. It's particularly useful for moving objects in the scene along the z-axis without having to manually specify the vector values each time. So this introduction sets the stage for further exploration of character movement, camera controls, and interactions within the game, leading into more advanced topics like input management, physics-based physics-based movement strategies, uh, and so next topic is yeah, again, player movement and rotation. So implementing. So to effectively gather player input for character movement, uh, for in Unity we employ the input class, which simplifies capturing a wide range of inputs, including keystrokes, mouse actions, and more. So specifically for character movement in your Hero Bond project, you'll utilize WASD and arrow keys, which facilitates movement through scripting. That also aligns with the camera's focus based on the mouse direction. So this process hinges on understanding input access and their configuration within Unity's input manager. So Unity's input manager, so which can be found on the under the edit uh, project settings, and you'll go to input, which predefines various input a axis like the horizontal axis, which by default responds to both left and right arrow keys, and a which is a and d keys. Inputs from these axes ranges between -1 and 1, where for example pressing the left arrow or a key generates a -1, indicating movement in negative direction on the horizontal axis, and releasing the keys resets this value to 0, and while pressing the right arrow or D key sets it to 1, indicating movement in a positive direction. So this system allows for a streamlined method for capturing input across multiple keys using a single line of code, enhancing code efficiency and readability. So to capture these inputs within your game, we use input dot get access method, specifying the access name horizontal or vector. Yeah, input dot get access method, which specifies the axis name, which is vertical or horizontal, as the argument. And this approach not only simplifies input handling but also incorporates Unity's uh, Unity's smoothing filter, making the input frame rate independent. For unfiltered raw input data, you can use input dot get access raw, which can be utilized for offering a direct unsmoothened input values. So while while Unity provides a set of default input configurations, customization is straightforward. Custom accesses can be added by increasing the size property in the input manager and renaming the new entry. So this flexibility supports a wide variety of input types and configurations, tailoring the input system to specific game requirements. And Unity's newer input system further expands on this functionality, uh, catering to broader range of platforms and input types, although not used in our project due to its complexity for our needs. So this system represents a significant evolution in the Unity's input handling capabilities, offering developers a more versatile and comprehensive approach to input management. So now let's try to apply this knowledge by discussing about this player movement script, utilizing Unity's input system to create a responsive, intuitive control scheme for our game. So the player behavior script. Yeah, this is your player behavior script. So this script will detect inputs from SD and arrow keys, translating these inputs into uh, a responsive character movement and a camera control, laying the foundation for an engaging player experience. So the player behavior script is a fundamental component for the player movement, the character movement in Unity, allowing both translation and rotation based on player input. So let's break down how the script works and its implication for game development. So the script starts with a public variable, move speed and rotate speed, which allows for easy adjustments in the Unity's inspector. So these variables determine the speed of the player's movement and rotation respectively. And we have private variables, private float variables, v input, h input, which are used to store input from the player, each frame representing vertical and horizontal inputs. And in the update method, we have input.getAccess vertical and input.getAccess horizontal, which captures the player's input from the keyboard or other input devices. So these methods return a value between -1 and 1, where vertical axis corresponds to up and down, which is W and S keys, which is input, and horizontal axis to left, which is to left and right, A and D keys, input. And I think we also have a translate. Let's translate. Yeah, I don't think I've added the translate method, but basically, translate method moves the player forward or backward uh, based on the uh, based on the V input. The calculation includes move speed. I think it's added in a different way here. Yeah, this is what I'm talking about. So, uh, yeah, the calculation includes the move speed multiplier and time dot uh, delta time to ensure smooth frame rate independent movement. And we will also have a vector 3, which so vector 3 dot we have a rotate, but I think I've removed the forward. So vector 3 dot forward basically is used to define the direction of movement in the forward, which is z axis direction of the player capsule. And what else? Yeah, rotation. And we'll also have a rotate method which applies rotation to the player based on H input. So with the rotate speed, with the rotate speed affecting the speed of the rotation, similar to the translation, and the time dot delta time is used for smoothness, and rotation is applied around the vector 3 dot up. Uh, so vector 3 dot up axis, which is y-axis, allowing the player to turn left or right. And did I use, yeah, so this keyword, so the use of this keyword, which is optional, clarifies that the translate and rotate methods are being called on the current game object, which is the player capsule. So breaking down the movement and rotation calculation into separate steps and enhancing readability and maintainability of the code. It's a bit, this code is bit different, but if you check your textbook code, it will make more sense. So this script lays the foundation. So when you, sorry, I forgot to mention, upon attaching the player script to the player capsule and entering the play mode, the player can control the capsule using the W, A, S, D or arrow keys, and the capsule moves and rotates across the inputs with the movement, speed and rotation speed adjustable using the scripts public variables in the inspector, unity's inspector. So this script is a foundation for character movement in unity, demonstrating how to utilize input data to control game objects dynamically. So by adjusting the move speed and rotate speed variables, we can fine tune the player's movement and rotation to fit the desired gameplay feel. uh, Next is camera. So adding a camera that follows the player in Unity requires a careful consideration of how the camera's position and orientation are updated in relation to the player. So let's discuss how to achieve the camera behavior. First is separation of concerns. So it's uh, it's essential to keep the camera behavior script separate from the player movement script to maintain independency in movement and rotation. So this ensures that the camera motion doesn't directly mimic the players, allowing for smoother and more controlled camera dynamics. So you create a camera behavior script and attach it to the main camera. This script will control the camera's position relative to the player. Here we define uh, so we basically define a public variable, it's not included here. So we define a public vector 3 variable, which is named, this supposed to be a public variable, which this is a the cam offset to determine the camera's position relative to the player. This offset allows for adjustments in the camera's direction and angle without altering the player's script or behavior. So by adjusting the cam offset values, you can position the camera uh, behind and slightly above the player, providing an optimal view for a third person adventure setup. And we also have a private transform variable to store the player's transform. This acts as a focal point of the for the camera. And in the start method, you locate the player's game object by the name and assign its transform to the target variable. um, this ensures that the camera knows which object to follow. And we have a late update method, which is used to update the camera's position after all the update method have all the update methods have run. This guarantees the camera moves based on the player's most recent position. So for that we use uh, transform point, so which with the offset cam offset to calculate the camera's position in the world space relative to the player. So this method takes the player's current position and applies the offset, uh, placing the camera in the desired location each frame. And we have a look at uh, method which is called to orient the play camera towards the player. This ensures the camera always faces the player, avoiding a consistent view regardless of the movement. So that's about this code. Yeah, basically the cam offset. It's supposed to be public. Um, so cam offset determines the spatial relationship between the camera and the player, affecting how the camera follows. And finding and storing the player's transform allows the camera to maintain a focus on the player, and updating the camera's position with the transform point and orienting it with look at in the late update method ensures smooth following behavior. So by structuring the camera behavior this way, you'll achieve a flexible and dynamic following camera that enhances the player's experience without directly linking the camera movement to the player input. So this approach provides a stable and consistent viewpoint, which is crucial for navigation and interaction with the game environment. So next is physics system. So Unity's physics system provides a robust foundation for simulating realistic interactions and movement within a game environment. So by utilizing rigid body and collider components, we can create objects that obey the laws of physics, offering a more immersive experience for players. So let's go deeper into these concepts and how they can be applied to create more realistic moments in Unity. So let's first understand Unity's physics engine, which is powered by NVIDIA NVIDIA Physics X, which simulates real world physics to bring your game to life. There are two core components you'll work with, which is rigid body component and collider component. So the rigid body component adds physical properties to game objects such as mass, drag, and the ability to be affected by forces and gravity. Rigid body is essential for any object that needs to interact with other objects or the game environment in a physical way. And we have a collider component, which basically colliders define the shape of the game object for the purpose of physical collisions. A game object can have multiple colliders known as a compound collider setup. So to accurately defining its physical boundaries. So colliders are crucial for detecting when objects enter each other's space. Collider should trigger events based on those interactions. And we have two movement types, which is kinetic movement and non-kinetic movement. So kinetic movement occurs when a rigid body component is present but not actively participating in the physics simulation, often controlled through script by directly manipulating the game object's transform. So this method marked by setting the rigid body's is kinematic property to true. So it's typically used for objects that need precise control over their movement without being affected by the physics engine forces. And we have non-kinematic movement. This involves applying forces to a rigid body component to move and rotate game objects. So this method is more dynamic and realistic, as objects will interact with the physics engine naturally, responding to gravity, collisions, and other forces as expected in the real world. So, so to achieve a more lifelike and dynamic movement for our player character, we'll transition from directly manipulating the transform component to applying forces to rigid body component. So this approach uses the physics Unity's physics system to create movement that feels more natural and is as and also influenced by the game environment and other physical parameters. So implementing a realistic locomotion to update our player movement to use applied forces. First thing you'll do is modify the player's that's why player behavior script, which adapt you'll basically adapt the script to apply forces for movement and rotation instead of directly setting transform properties. So this involves using rigid body dot add force for forward and backward movement, and rigid body dot add torque, which is for rotation. So you'll adjust the body settings. You'll fine tune the rigid body component attached to the player capsule. Ensure mass, drag, and other properties are set to achieve the desired movement, responsive and feel. Experiment with different forces, mass settings, and drag values to find a balance that provides a satisfying and realistic movement experience. Also, pay attention to how player character interacts with the environment and adjust the physics properties as needed. So, by embracing the Unity's physics system for movement, you create a game that not only looks realistic but also feels engaging and dynamic to the player. This fundamental knowledge of rigid body and collider component, along with practical exercise in applying forces for movement, sets the stage for further exploration and creativity in game development. So we have a couple of other topics. We'll discuss that in the next session.